A square root of a number is a number such that when you multiply something by itself, you get that number. So it's easier with showing examples. So for example, the square root of 64 is 8 because 8 times 8 is 64. The square root of 49 is 7 because 7 times 7 is 49. A perfect square is a number that when you take the square root of it, you get a whole number. So it will be helpful in your math future to know the first 10 perfect squares. So the first 10 perfect squares are 1, because 1 squared is equal to 1. 4, because 2 squared is equal to 4. So when you take the square root of 4, you get 2. Think about 3 squared. 3 squared is 9, so 9 is a perfect square. 4 squared is 16, so 16 is a perfect square. 5 squared is 25, so 25 is a square. So square root of 25 is 5, that's a perfect square. 6 squared is 36, so 36 is a perfect square. 7 squared is 49, so 49 is a perfect square. 8 squared is 64, so 64 is a perfect square. 9 squared is 81, so 81 is a perfect square. 10 squared is 100, so 100 is a perfect square. Evaluate each square root. So we're going to evaluate these. So the square root of 64 is 8. The square root of 121. So you can, if you don't know what that is, you can try that in your calculator. So the square root of 121, do the square root button, is 11. And then the next one, the square root of 16 is 4, because 4 squared 16, and I put a negative out front because this one has a negative. The square root of 49 is 7, I put a negative out front. So estimate the following square roots to the nearest integer. So which one is it close to? So if you think about your perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, so on. So which of these numbers is closest to 27? Well, 25 is, so this has to be close to 5, because the square root of 25 is 5. 72 is closest to 64. So this is closest to -8, approximately. 50 is close to 49. The square root of 49 is 7, so this is approximately equal to 7. And then 22 is closest to 25, so this is approximately equal to -5. And then letter E. You can use the formula D equals square root of 1.5h to estimate the distance in miles to a horizon line when you are and your eyes are 8 feet above the ground. Estimate the distance to the horizon seen by a lifeguard whose eyes are 10 feet above the ground. So 8 feet above the ground, and we know 10 feet above the ground. So that means we need to plug in 10 for h. So I do distance equals the square root of 1.5 times 10. So distance equals the square root of 15. So I'm going to put the square root of 15 in my calculator. So square root button 15 is about 3.9. So I'm going to put approximately, because I rounded, 3.9 miles. Okay, in the beginning of the year we talked about rational numbers and irrational numbers. Rational numbers are whole numbers. So numbers that don't have a decimal, or they could also have decimals that stop or repeat. They have to have a pattern. Irrational numbers are decimals that don't stop and don't repeat. So, for example, identify each of the following numbers as rational or irrational. So if you put the square root of 18 in your calculator, why don't you put the square root of 18 in your calculator? So if I do 18 square root, I'm going to get this crazy long number, 4.2426406.8. This number is a decimal that does not repeat. There's not a pattern. No pattern. So this is irrational. Now I put the square root of 144 in my calculator and I get 12. 12. So it's a decimal that stops, basically, because it's 12.0. So this is rational. Letter C, this decimal stops, so it's rational. Letter D, 1, 2, 1, 2, this has a pattern. The pattern is 1, 2, 1, 2, 1, 2, 1, 2, so this is rational. And E, this does not have a pattern, so it's irrational. And then F is just pi. So if you put pi in the calculator, 3.14, it's a number that does not have any pattern to it, so it's irrational. Decimal goes on forever, doesn't have a pattern.